Alright, here's the second video for Chapter 12, Part 1. Oh my goodness, we're already moving on to Part 2, my mind. Chapter 12, Part 1, Test Review. Okay? Last time we were doing mole to mole, and this time we're going to see about mole to mass. Alright, here's your question. Titanium is a transition metal used in many alloys because it is extremely strong and lightweight. Titanium is tetrachloride, and it's extracted from titanium oxide. Titanium tetrachloride is extracted from titanium oxide using chlorine and coke. They already gave you a balanced chemical equation. It was super nice of them, by the way. Then the first part is, what mass of Cl2 gas is needed to react with 1.25 moles of TiO2? First question you have to ask yourself, what kind of question is this? Well, in the actual question itself, I see the word mass here, and I see the word mole there. They gave me moles, they're looking for mass. That means we're going to do mole to mass. So I'm using these steps right there. Number one on the step should always be the same. Number one should always be write the given. My given is the only number that I can see there. The only number that I can see there is 1.25 moles of TiO2. Done with number one. Step two, write the mole ratio. Remember, this is where it can get a little tricky. This, I'm going to have to look right here at that balanced chemical equation. I look at the balanced chemical equation. I am dealing with TiO2 and Cl2. So my mole ratio is going to deal with both of those. It's going to be an either 1 to 2 ratio or a 2 to 1 ratio. I look at what I already have in my railroad tracks. I have TiO2. I need to get rid of that. So my 1 mole of TiO2 is going to go on bottom. Remember, I got 1 mole from looking up here. There's no coefficient, so that means that it's a 1. Then I put the other component of that, the other part of the ratio, on top because that's the only other place that it can go. So 1 mole of Cl2. Again, I got that from up here. Okay. Done with part 2. Step 3. Now I have to do the molar mass. I have to do the molar mass. The only thing that I have right now, I only have Cl2. So I look up Cl on the periodic table. Its mass is 35.453 grams. I have 2 of those. So my little handy dandy calculator. I get 70.906 grams for Cl2. Then I have to look and see where that needs to go on my railroad track. If I had grams here, then I'd have to put grams on bottom. But I don't. I have moles. So my grams are going to go on top. On bottom, I need to put the 1 mole, because remember, every time you look on the periodic table for molar mass, it's always paired with 1 mole of that substance. My mole of Cl2 crosses out. I'm left with grams of Cl2, which is exactly what the question is asking me for. I multiply across the top, divide by the bottom, multiply together. Put it in my calculator. And I get 177.265 grams of Cl2. And I need to look at my sig figs. I only need 3 of them. So my final answer is 177 grams of Cl2. I want you to try B. I want you to try B. Pause it and try it. Okay. looking at your steps, remember, don't forget these steps over here. Looking at your steps, the first one's always the same. The first step is to write your given. My given is the only number in there. So go ahead and write that down now. 1.25 moles of TiO2. Same given we had earlier, and that's okay. Step 2 says to write the mole ratio. I look up in the actual equation. I'm dealing with TiO2 and C. I put my 1 mole of TiO2 on bottom, so it'll cross out. And every time I have 1 mole of TiO2, I always have 1 mole of carbon. It is a 1-to-1 ratio. Then I look at my steps. Now I have to have the molar mass of what I'm looking for, which is carbon. I look on the periodic table. I see that the molar mass of carbon is 12.011. And I know that I only have 1 carbon, so I don't have to multiply that by anything. I also know that my grams need to go on top because it's right beside a 1 mole, or it's right beside the mole. And I know that my 1 mole of carbon has to go on bottom, so I can cross that out. Step 4 says to calculate my answer. Multiply everything on top, divide by everything on bottom, multiply together, and you should get 15.014 grams of carbon. Checking sig figs, I only need 3 of them, so it's 15.0 grams of carbon. Don't worry about doing C. All right, I'm going to go ahead and stop this video, and we're going to do one more on mass to mass. So go make sure you watch that one. That way you can practice some problems on that.